Good morning, everyone. My name is Jerry Kohler. I'm Director of Business Development for Graybar. I'd like to welcome you today to Graybar's G2 Talk session named Integrating Motor Control Information into Enterprise Business Systems. This talk is part of a webinar series that we offer each month for our industrial customers. We have a great discussion lined up for you today, but before we get started, I'd like to cover a few housekeeping items. First of all, if you were one of the first 50 people who joined this presentation, you'll receive a coupon for a free cup of coffee, courtesy of Graybar, as a thank you for your time today. Also, at the bottom of your screen, you'll see a box for questions and answers. Feel free to submit your questions throughout the presentation. We'll address as many of them as we can, as time permits, at the end of the presentation. Lastly, our G2 Talks are also archived on the graybar.com website, so you'll be able to view this presentation again or recommend it to others. At this time, I'm pleased to introduce today's speaker, David Marshall. He's Business Development and Product Launch Manager at Schneider Electric. Dave's been with Schneider for over 19 years and has worked as an OEM manager for both material handling, crane and hoisting, a segment manager for HVAC, contracts manager for major accounts, and TeSys Task Force leader for the launch of TeSys U and TeSys T. Dave has a Bachelor of Science degree in Aerospace Technology, also completed an EMBA program, both at Kent State University. So without further ado, I'd like to turn the presentation over to Dave. Take it away, Dave.
Jerry, thank you, and thank everybody that's on the line here for your attendance today. Hopefully this will be interesting and informative for you. We're going to be talking about TeSys T, which is a flexible motor management system, and I will, before I guess talk too much about the product here, I want to let you know what applications this product might have great values in that hopefully mean something to you, the folks on the phone. TeSys T is a motor management system, and I'll actually tell you it's a smart motor overload. It actually can be used in a lot of process industries, so things like mine metallurgy in the cement industry, oil and gas, it's a very, very high fit for it. We can actually use it on commercial sides as well for things like water, wastewater, and there are actually even motor applications that go along with wind energy that TeSys T can add value. Probably, though, more so on the industrial applications side, TeSys T has a lot of applications. More than 99% of industrial processes are controlled by electrical motors. And so the feedback that we actually get from electrical motors can tell us a lot about how the processes are running. So this is true for things like conveyor lines, manufacturing systems, but it also has applications even in commercial applications like commercial buildings and how things run like elevators or HVAC. So before I tell you some of the details here, let's just see if we can tell you what TeSys T is. In the upper right-hand corner there you see that LTMR. That looks like, and it actually is, a solid-state overload relay that you would put with a motor. There's actually current transformers. There's 3 holes in the back of that unit for 3-phase power. In the picture on the left side there shows only one of the conductors coming through it. But what we can actually do with a current transformer is actually detect the amount of current running through a wire. And so with this particular unit, we can actually measure current. The LTME is a device that actually mounts adjacent to the LTMR, and that actually has 3 voltage taps on it so that we can actually do current with the LTMR and then voltage with the LTME. And so with current and voltage, we can actually do power in watts. So we're actually telling you that we not only can measure the current here, but we actually have an energy meter built right into the motor overload. The units also have inputs and outputs on them that allow us to actually control different functions that we have, either obviously on the inputs having devices like solenoids or other actuators that we can detect what's happening, and then outputs where we can turn things on and off. And then finally at the bottom there is what they call the LTMCU, which is an HMI device that we can actually mount on the front of an enclosure or an MCC bucket, but there's other HMI options I'll talk about here as well. So if we say what capabilities does this product actually provide us for those processes that are controlled by electrical motors, we can actually have motor protection. We can actually meter or monitor the functions that the motors are actually controlling. Very, very important here is these units actually communicate over industrial protocols and actually now over Ethernet protocols. We do have abilities now for actually putting terminals or monitors here that take this data and actually put it in useful information like SCADA systems or building automation systems. We have configuration software to make it easy to set up here and actually predefined modes of operation that allow you to use standard setups for most of your applications. This slide's a little technical here, but it is one that, again, I want to show you the great capabilities of the product. There's actually 3 different sizes of current ranges that go through 8 amps, 27 amps, or 100 amps, where we actually run wires right through the current transformers in the unit. We can actually go to much, much higher amperages, up to 1,000 amps. In those cases, we'd use external CTs. We do have on the LTMR 6 inputs and 4 outputs. We have capabilities, though, for both a temperature or thermistor input coming from a motor winding and also external ground inputs coming from an external ground CT. And then finally, you said it communicates. The industrial protocols we communicate on are Modbus, Profibus, DeviceNet, and CAN Open. But we actually have Ethernet capabilities, and I'll talk a little bit more about those later on in the presentation. When it comes to control power, most network-based control power is 24-volt DC. But you may have applications where you need to have higher voltages, so we have control capabilities also between 100 and 240 volts AC at either 50 or 60 hertz. So it's independent of, U.S. would be 60 hertz, but most of the European world and some in Australia would be 50 hertz. As well with that voltage measurements, we actually add 4 more logic inputs. So we have a total of 10 logic inputs that we can put in this device. And then different capabilities with the display. Quickly again here, we actually say, well, can you tell what kind of product it is based upon the reference number? And the answer is yes. We actually, through the part number, we can actually figure out what size the unit is, the network it will hook up to, and the control power that goes along with it, which is very, very useful at the time of integration. Now, we talked a little bit here about different communication networks, and one thing here I wanted to show was where we are going, I'll say, as an industry with regards to industrial protocols. Modbus is one that Schneider Electric uses as our native industrial protocol, but you can see there's really a big growth in Ethernet-based protocols, and this is, I think, all of the industrial protocols are losing right now to Ethernet-based protocols, and there's many advantages that we'll talk about in using Ethernet-based products. One of the things we say here is that this product is very, very flexible in how it will design into either existing equipment or new equipment. Is that the size of it is actually done on purpose because it's meant to retrofit from existing overload relays that might be in motor control center buckets or MCC buckets, and whether it be any of our squared E buckets or it could be our competitors, GE, Siemens, Allen Bradley buckets, Eaton buckets, we can retrofit this product in every existing one. I'll tell you we've already done that. Again, the current ranges with this, 100 amps and under, native to the unit, but we have software where we can actually run the secondary of current transformers through the TeSys T and actually then have CTs up to 1,000 amps, which is over 700 horsepower at 480 volt, which typically is where medium voltage would be used. Also, if you have export requirements here or other country requirements, This device not only is UL listed, it has an IEC listing, a CSA listing for Canada, and a CCC listing for China. So most places that you may export products or have products come in, we can actually meet with this. As well, in the U.S., we would like to know on a 3-cycle short circuit fault what the interrupt rating of this device would be. And so it's a full 100 kA interrupt rating on this device at 600 volts. So it has quite a good capability there. And again, it is designed for retrofit of existing units, so we can actually turn older motor control centers into smart motor control centers by integrating TeSys T into the design. Now, setting this up is only as good as the software, and we actually have a software called SoMove. It's very intuitive. It's PC-based software so that you can actually program multiple units here, either via the network or there's a front connection you can put in right from a PC. We can as well integrate these with programmable logic controllers. We do have derived function blocks available with this device. And then multiple connections to different kinds of HMI or human-machine interfaces go along with this. Now, somebody said, how much programming really has to go into this particular product? And the answer is actually not that much, because what we've done, we've actually taken the 10 most common motor control applications. One might be a single-speed application in one direction, but you might have single speed with a reversing motion on the motor. Sometimes we have dual wound motors or piggyback motors where we might have 2 windings to control, so we can actually do 2-speed applications as well as 2-speed and reversing applications. Different connections for Y and delta, we can actually identify those type of wiring applications inside these 10 predefined control modes. And so they're actually in the SoMove library, and it makes the setup of this, it's really a configuration more so than a programming, if it's in these 10 predefined modes. This is, I'll say, the whole scheme, if you look at here, of what products would we actually need to make a full motor management system. You can see at the top different devices. Each device has a single protocol with it, meaning, and there's only one. Actually, the Ethernet device has Modbus TCP, and actually I'll tell you a little bit more about the fact that in September we'll actually have Modbus IP, Ethernet IP as well. And the expansion module is only needed if you need to measure voltage or you want to do power output. A lot of process can be controlled just fine by using current input, which the LTMR units at the top will do. We talked a little bit about the fact that we can do remote monitoring with many HMI devices and as well as then hook up to PCs or other controllers. But again, if we do have over 100 amp requirements for motors, we can put external CTs that do hook up very nicely to the TeSys T. And we can do grounding either by using phase imbalance with the external or internal CTs, or we can put a single ground CT that we can do phase imbalance, phase loss, phase reversal, all those phase functions and ground functions with a ground CT here as well. Now, when it comes to maintenance, you say, okay, I have a device here that can be installed. It would give me intelligence for my motor control centers, but how easy is this to maintain? I'm going to tell you it's fairly easy. We do have some health circuits in there that will actually tell you over the network, is the unit working properly? Is it wired properly? It'll even tell you, like I said, if wires are mislabeled, it will detect that. We do have another function here for the Ethernet versions called FDR, or Fast Device Replacement. And this is actually a situation if you had a maintenance function where you needed to replace a device. The setup for that device, all the settings, will actually be assigned to an IP address. The settings will be stored in the unit itself, but it'll actually make a mirror of its settings on the PC or PLC that's controlling the unit. So when you put a new unit in, it'll actually detect the IP address. and will actually download all the settings from your controller right back into the device, so no programming has to be done for maintenance. It'll all download automatically within seconds after it powers up. We also have embedded web pages already designed into the unit, so you don't have to do any web designs, for the ability to get all sorts of data out of the unit. This unit is also designed to be used in very, very harsh environments. All the boards are conformally coated so that having dust, types of solvents, those types of things that you might normally have in either a cement plant or oil and gas, this device is very, very resilient in those cases because, again, of the conformal coating and even vibration. A very, very robust design with it. So what will I be able to monitor with this device, and how does that help me in prediction? And again, what goes along with monitoring and prediction is talked about as uptime. How do I keep my system running at its peak production, and how can I get information that tells me about a problem that's occurring, but it's not a critical problem yet? And this is one of the big advantages of TeSys T. We measure current, we measure voltage, we measure power, but we can actually collect data over time to actually do trending on current, trending on voltage, trending on power as well throughout the day or throughout the operation of a cycle. How we can use this trending, TeSys T has one big advantage, is that we can do alarms and faults at different settings. So we can separate alarms from faults. So you can actually set, say, an overcurrent alarm on a device that maybe pulls 50 amps. You could set an overcurrent alarm, say, for 65 amps, even though you might set the fault for 100 amps. And if you ever do get a current at 65 amps, the amount of time between it's at 65 to the time it gets to 100 is the amount of time you actually have to do predictive maintenance. And if you look to the bottom there, there's really three big benefits in this process availability or uptime. Is the predictive maintenance, it's knowing when equipment is operating outside of its norm, and being able to have fault diagnostics as to what is the fault. Is it an overcurrent? Is it an undercurrent? Over voltage, under voltage? It could be a power factor problem. You can get all that data out of this particular unit to have real-time diagnostics of the faults or the alarms, and then you can actually do a corrective action knowing what you need to fix, where you need to fix, oftentimes before the device will actually fail. So it basically gives you information to keep you up and running, which is incredibly important for any process that you have. As well, a lot of people will actually have software updates on equipment, but when it comes to firmware, they oftentimes have to replace devices. One of the beauties of TeSys T is we have both software and firmware updates available through the programming of the unit. So in this case, we don't need to replace devices. If we have firmware updates, we can actually do them through programming into the unit as well. So from a design standpoint, you're saying you've told me a lot of information in the last 20 minutes about what it can do, but how do I actually apply this to make sense for my applications in my processes? And there's probably three stages here. The first one is the main purpose of an overload relay is to protect the motor winding. And having a solid state overload does that very, very well because it's not heat sensitive. So it will actually be very, very repeatable in the points that it trips. Plus it can give you information if there is a fault. What kind of fault is it? Is it a long start fault? Is it a jam motor? Or is it a phase loss or a phase imbalance? But the next level is it basically the management of your application or your machinery is taking data from the unit beyond the solid state overload relay and taking a look at measurements like current, voltage, power over time actually being energy, so it'll actually do energy metering. And it will also monitor power factor. So if you have power factor or even harmonic issues, you can detect it through this unit. And then finally, at the high level here, if you actually set up in the metering and the monitoring for alarms that will tell you when your equipment is running out of norm, this can actually be part of the process management that goes along with your facility based on the data that, again, you get out of this unit being the TeSys T Motor Manager. So again, we take a look here at other usages, and again, this is more from a design standpoint. We've talked about using it as a basic short circuit overload relay, but one of the beauties in point B here is the fact with 10 inputs and 4 outputs, I can actually have fully networked communication to other devices that might be adjacent to where the motor's running. So solenoids, valves, pressure settings, other switches or relays that you might have that control a process, you can actually use the connections into TeSys T to put these into the network. So having this kind of I/O flexibility, very, very useful in process. And then finally, again, the idea of the motor management is, again, by setting norms, I can actually use the device to set predictability and set alarms separate from faults that will allow me to actually schedule maintenance based upon where I set the alarms for these devices. Talked about some new additions, and actually we're looking to have this in August for launch in September, is the new TeSys T that has Ethernet IP protocol. One of the things for those folks that do process control, the new TeSys T with the Ethernet IP protocol will do both Modbus TCP IP and Ethernet IP in one device, and we do that through the software. But we've also added rapid spanning tree protocol into this device. So if we have any situation where we have a break in the cable or in the communication here, rapid spanning tree protocol will actually allow us to, within less than 1 second from another supply point, basically pick up that device from a different direction. So this is very, very useful for us because we can not only do warm standby, but we can actually do hot standby capabilities now with this device using the Ethernet IP protocol with the rapid spanning tree protocol that goes along with it. This is the point here where, for those that are very, very technically say, what can I do with this particular device? The next 2 slides I have here, I call the chef's cupboard. Is that if I treat the way an engineer designs things as he's a chef designing something very custom, what are the ingredients he has to work with? And TeSys T has a lot of capabilities that I would call ingredients for creating a solution. So from a sensing function, we know that we can actually sense thermal issues here that would be thermal sensing of wire. We can actually sense current, we can sense voltage, and we actually have capabilities to do things based on power. So we can actually do load shedding here. We can have underpower, overpower, and power factor measures that go along with this. This next slide, unfortunately, is the busiest slide that I've got, but it's the most interesting as well, because this is a list of all the metering functions and as well the fault monitoring functions that we can do with TeSys T. This really is the chef's cupboard right here, is that we realize here that we can do things. If I look at the left, what can I meter? I can do active power, reactive power, power factor. It's a laundry list, if you will, of incredible metering functions I can get right out of the overload, and every motor has to have an overload, so it's very convenient to not have a second device to pull this information. But maybe even more useful is the fault monitoring functions here of what things can I actually detect that would help me identify either alarms or faults that would allow me to do maintenance based upon the fact that I know how to fix it before I have to make the trip. And again, we've got things here, if I look at, say, the current, phase loss, phase imbalance, jam, long start, Or on the grounding side, which can be very important for processes, is having the capability to know, is it an internal ground current, an external ground current? Do I have an undercurrent or an overvoltage? These all are very, very useful from a standpoint of identifying grounding problems. And grounding problems can be some of the most nagging issues in keeping a process up and running. So you've seen a lot of information here. What I want to tell you here, you say, well, does this really come together to be of value for me? And I'm going to tell you about an application that was recently sold through our Gray Bar location near Abilene, Texas. This is for a large oil and gas refinery that is in that area. And we've recently installed a large installation of intelligent MCCs that have TeSys T, along with some switchgear and some medium voltage equipment. But the big reason that they chose the Schneider Electric TeSys T product for this had to do with its ability to detect ground fault issues, but separate the ground fault in an alarm from the tripping functions. And not all devices can do that. And so they actually use mild ground faults with an alarm to basically be indications of where they had potential problems in either wiring that might be affected by vibration or corrosion or other sources of where the ground fault actually helped detect. And they actually tied this in with their SCADA systems to basically allow them to have full diagnostics using the data input coming from the TeSys T. So this was a big savings for them. It saved a lot on the maintenance and in the predictive capabilities here of maintaining this equipment. And so this is a great example of where TeSys T really is a game changer for Schneider and for you folks, our customers in Gray Bar. So at this point, I'm through here. I'm going to turn it back to Jerry, and we can certainly ask questions that I can answer here. I'd be welcome to.
Thank you, Dave. Excellent presentation. At this time, we'd like to address some of the questions that have been submitted. As a reminder, you can submit a question using the Q&A box at the bottom of your screen. Let's see if we have any questions coming in. We do. Dave, first question. Can we use this device for medium voltage applications?
Very good question. At this point, TeSys T can be used up to 830 volts is what it can detect. Is it's UL listed, it's actually at 600 volts only. And so we do actually, Schneider does have something called a CPAM relay that we can use for medium voltage applications. It's similar to this. But typically this is a low voltage device. And if you need it to be UL listed, 600 volt and under is where it needs to be listed at.
Thank you, David. Here's another question that just came in. Dave, can I retrofit TeSys T in existing motor control centers?
Great question. Absolutely, yes. The design of TeSys T was actually done on size to actually replace existing either traditional or solid-state overload relays. As well, that device can actually be mounted up to 10 feet away from an existing motor as long as we can get the secondaries from CTs into the unit. So I can tell you that we've retrofitted every major brand of motor control center with this already. It's been very, very successful in doing so.
Thank you, Dave. Another one that just came in. With the Ethernet IP capabilities, will there be an app note on how to integrate this into a Rockwell control platform?
Whether there'll be an app note or not, we will have basically instructions on that because Ethernet IP is an open protocol, but obviously it's mostly associated with Rockwell. And it is one of the integrations that we'll have. So we will have app notes for it it might not necessarily be in a note that is attached to the device itself, but Schneider will actually have that available on the website for download.
Thank you. Another question that just came in, and I'll take this one, Dave. It says, I'm interested in learning more about TeSys T. What are the next steps? Well, from a Graybar perspective, we can get a local Graybar automation specialist to call you and set up a visit if you'd like, or you can simply call 1-800-GRAYBAR, your local branch, or go to graybar.com, and at the top of the web page, there's a link for locations whereby you can find a location by a zip code. Hopefully that answered that question. Another question that just came in, will Profinet be added?
Profinet is on the roadmap, but I can't tell you that we'll actually have Profinet in the next 2 years or sooner. We kind of viewed both Ethernet IP and Modbus TCP probably hitting about 90% of the applications. Where we do see Profinet, though, is actually in automotive. It seems to be definitely there, and it is on our roadmap for our next development would be Profinet, but I can't give you a date.
Thank you, Dave. Doesn't seem like we have any more questions. So if we do have any questions, any further questions, we'll have a Graybar representative contact you directly and have that question answered for you. So it's about wrap-up time. We're all about out of time at this point. So as a reminder, this presentation will be archived on a graybar.com website. Again, thank you for your time today. We hope you'll join us again next month on July 29th when we'll address short current circuit ratings with Eaton's Busman Business Unit. Thank you, everybody. Have a great day.